Good morning, everyone. Thank you for this opportunity to present what we are doing at CIEMAT. CIEMAT is a large research center, government research center in Madrid with about 1,500 workers. In the technology department, we are actively working in PET imaging. Our main area of interest is develop the technology for PET MR imaging. The clinical part is being supervised by Hospital Puerta de Hierro, a hospital of the Madrid area. So essentially what we are doing is developing an insert for functional imaging of the human brain compatible with magnetic resonance. So it will be installed inside the bore of a clinical magnetic resonance. The main developments that we are following are we are using LISO scintillators, but monolithic, not the usual segmented design. We have also developed dedicated positioning algorithms for these scintillators. We are using and have experience in front-end readout for these detectors and also on all the data acquisition electronics. The technology department has worked in high-energy physics at CERN for many years and also in the AMS experiment. So we have a lot of experience on this data acquisition problem. So just a few shots of what we are doing. So you see we have these big scintillators. They are not segmented. They are just a single piece of crystal. We have Hamamatsu APD arrays for magnetic compatibility. We have a matrix of 8×8 pixels for each crystal. We have these neural network positioning algorithms. We are capable of getting spatial resolutions of the order of 2 millimeters, continuous coordinates, so I'll show you some results afterwards. So we have also a dedicated ASIC, which reads the 64 pixels, so these are two independent blocks. Sums along rows and columns as a trigger for energy selection and also a constant fraction discriminator for precise timing of the order of nanoseconds for the PET coincidencing. So we have a coincidence buzz, we have the data readout cards. This has all been designed and done in-house. And also the mechanical design, so the gantry is vertical, so we'll have the LISO detectors in the isocenter of the MR, then front-end electronics, and at the back, where the magnetic field is lower, we'll have all the data acquisition. So just a few results. You are invited to check these articles if you want the technical details. So from the positioning point of view, we have about 2 millimeters full width at maximum resolution, continuous coordinates. We have about 13% energy resolution for the PET discrimination. So here you see when you use the PET triggering, we just select the 511 kV peak. We have imaged point sources. We have imaged some Dorenzo-like structures. So we have here extended sources. We can separate them. And our wish list, so essentially for this collaboration, we can provide our expertise on these detector technologies, front-end and electronics readout. We are interested in the applications of PET and PET MR, which is a very fresh subject, and also in the integration of PET and MR technologies. Right now we are moving towards using silicon PMs for the light readout of the scintillators, and we are using APDs because this project started some time ago and there were no silicon PMs available back then. And for the context, I am a senior researcher at the technology department, and also the director of the technology department will be glad to hear from you. Thank you very much.